video if you don't mind. So, last time we talked about recursion, how it's splitting a problem up into part of it you can solve now and part of it you can solve later, right? And some of the things that we saw were you have a base case, which is the simplest version of the problem, and then you have the recursive case, which is sort of a similar problem to the big problem that you have right now, but slightly smaller. Okay, so let's see, factorial. I think we already wrote that one, didn't we? We wrote that in Eclipse. Yeah, we did. So let's go and go to this bunny ears problem. So it says we have a number of bunnies, and each bunny has 2 big floppy ears. We want to compute the total number of ears of all the bunnies recursively. Now, if you wanted to count the bunny ears iteratively, you would just say 2 plus 2 plus 2 plus 2 plus 2 plus 2 plus 2, right? You know, 3 bunnies, 2, 4, 6. So there you are. Got it, Jeremy. Which one was that?
7.
And you can do, are you going to do the other one or not?
Can I practice some?
You can practice it, sure. Then take it on Monday. So iteratively, it's no big deal. 2, 2, 2. 2 times 3, that's 6 years altogether. But we want to try to think recursively, okay? And so the easiest way to think recursively is to practice with simple problems that you can solve other ways. So here we have n bunnies, okay? And I want to split this problem up into 2 parts, something I can do right now and something I can do later, right? So the part that I can do right now is I can count the ears on 1 bunny, and the part that I'm going to save for later is count the ears on the other bunnies. Make sense? And I'll take the number of ears that I get on this bunny plus the number of ears that I get on all the other bunnies, and that's what I'll send back. That's what I'll return. Does that make sense? Okay. So let's that's kind of how we're going to break the problem up. Let's think about the base case and let's think about the recursive case. So the base case, the simplest version of this, okay, is just dealing with, like, what's the most basic situation I could have?
2 times 1.
Okay, so 1 bunny, right? So the base case is 1 bunny. The recursive case is more than 1 bunny. Right? If there's 1 bunny, then I'm sending back 2. You know, my count is 2. If there's more than 1 bunny, this is where I split up. I'm going to count the bunny that I have right now. So my count is going to be 2 plus the rest. Right? That's what so it helps to kind of think through the problem. What am I going to do now? What am I going to do later? Think about the base case. Think about the recursive case. And so now let's go ahead and do some programming. So it's always best to do the base case first. So I'll say if bunnies equals 1, then I'm just going to return 2. I'm sending back 2 for the bunny ear count. Otherwise, I'm going to split it up. The bunny that I have right now, so I'll say return 2 plus the rest of the ears. I guess I should kind of, maybe I'll, this part right here, you know, count the ears on one bunny, you know, what I can do now plus the rest, that's kind of all dealing with the recursive case. So maybe in our next problem, I'll see if I can simplify that a little bit. Now, how am I going to count the rest of the ears? Go ahead, just think out loud. How am I going to count the rest of the ears? Yeah.
If else more than one bunny.
Yeah, so I've got that. Yep, I've got that. I already have it, so that's the section that I'm in.
Oh.
So I guess I could say this 2 right here represents I've picked up one of the bunnies. There's 20 bunnies laying around. I've picked up one of them. I've looked at it. I've counted its ears, right? How many bunnies are left? If there were 20 initially, and I picked up 1. 19. Okay? So what I want to do is count the number of ears on the other bunnies, right?
Times 2. Bunnies times 2.
Right, but yeah, the bunnies times 2 is I could do that at the very beginning and it would be finished. What I want to do is I want to call this method again bunny ears, but instead of calling it with the same number of bunnies that I had initially, I'm going to say bunnies minus 1. Yeah, and the times 2, it's going to work every time, but that's like an iterative way. We're trying to have it so that this method is going to call itself. I guess I should have reminded us of that. So yeah, fundamentally, we're going to, somewhere in this code, if it's going to be recursive, we're going to have to call this method again. Oh, of course, I'm not right on the first time. This says bunny ears 0. Okay, so there's another base case we need to think about. What if bunnies equals 0? We can just say return 0. Kind of making sense? All right, let's go do another one here. What's next? Fibonacci. I'm going to hold off on Fibonacci for just a second, okay? Bunny ears 2. Okay, well, let's look at bunny ears 2. Which test is this, Ivan?
It's the first one.
So test 7?
Mm-hmm.
Okay, got it.
Can I practice the second one?
Yep, that's fine.
Take it on Monday.
Yep. Alright, let's look at bunny ears 2. We've got bunnies standing in a line numbered 1, 2, 3, all the way up. The odd bunnies have normal 2 ears. The even bunnies, the one at 2, 4, 6, 8, 10, will say have 3 ears because they have a raised foot. Okay, makes perfect sense.
Yeah.
Recursively return the number of ears in the bunny line from 1 to n without loops or without multiplication. So we've got a bunny here, bunny here, bunny here. All right, you get the idea. So this is number 1, 2, 3, 4. This guy we would want to say has 2 ears, but this guy who's even number 2, he also has his foot up, and so he has 3 ears, 2 ears, 3 ears, so on and so forth. Okay. What we want to do is we want to count how many ears we have recursively, some method that's going to call itself. Okay. So that means we want to do something to split this problem up into a part that we know and then a part that we'll save for later. Okay? So these bunnies go all the way on. Normally, if you're going to split a problem like this, so this goes all the way up to number of bunnies. if you want to split a problem up into a part you can do now and a part you can do later, you can either split it up where you deal with the first part, like you deal with this guy, and then save the rest for later. Okay? Or you can do it the other way around, where I'm going to deal with this part right now and then save the rest for later. Okay? And just, I kind of know a good way of solving this one, and that's what I'm going to tell y'all. This is the way we're going to solve it. We're going to solve, and we're going to look at the very last bunny and see how many ears that he has. Okay? And then we're going to add that number to whatever the rest is. Okay? So, for our recursive case, is we're going to say the count, the number of ears of the last bunny, and then add that to the number of ears on the rest. So deal with him now, and then deal with the rest. Now eventually, we're going to work our way down till we have our base case. What's our base case, folks? Eventually, I want this to stop. I want this process to not go on anymore. When do I want it to stop? At 1, okay? So, base case is when the bunnies equals 1. When that happens, what's my count going to be?
2.
Okay? Yeah, then my count, or I should say my ears, is going to be 2. Does that make sense? So let's see if we can. So say if bunnies equals 1, return 2. And you know what? Based on what they did before, I think I'm gonna deal with bunnies equals 0 just in case. If the number of bunnies is 0, what should I return? 0. Yeah, no ears. Otherwise, I'm going to return the number of ears of this bunny plus the rest. See if that makes sense. If there's 0 bunnies, then there's 0 ears. If there's 1 bunny, there's 2 ears. Otherwise, I'm going to count how many are on this bunny, on the one at the very end of the list, and the rest. Okay, so
Return.
So I need to figure out, for the very last bunny, does he have 2 ears or does he have 3 ears, right? So let's go ahead and do some examples here. What if the very last number was 10? How many ears does he have?
3.
Okay, because, how do you know that?
It's an even number.
You're right, if it was 15, how many?
2.
How do you know that?
It's an odd number.
Okay, so now this number right here is the number of bunnies. If there's 10 bunnies, then the last bunny is number 10. If there's 15, then the last one will be number 15. So does anybody remember how you determine whether a number is odd or even?
Do the remainder thing.
Mm-hmm. And do the remainder thing with what? With what divisor?
2
Mm-hmm.
equals 0.
Equals 0, yeah. So we'll say if bunnies remainder division 2 equals 0, that means it's even, right? So 3, because we've got 3 ears, plus the rest. Else, return equals. 2 plus the rest. So we're kind of building this. Rosa, how am I going to figure out how many ears the rest have?
The rest? Oh, you just, again?
What's that?
Go through again.
Go through again? Okay. So call this method again. Bunny ears 2. And what am I going to put in the parentheses?
Bunny.
Almost totally right.
And it's -1?
Minus 1. Does that work for y'all? Rafi, good?
Yes, I just misspelled.
You get an extra one in there maybe? I've got 2 altogether. Try that. Do you have more all the way down here?
No.
Well, now it's gone. Yep.
I will start. Because no food.
No, you were right the first time. If bunny 1 is your 1, your 3 plus bunny. All right. All right, let's go back to that Fibonacci one. All right, Rob, while I erase the board, go ahead and read to us about Fibonacci sequence.
The Fibonacci sequence is a famous bit of mathematics, and it happens to have a recursive definition. The first 2 values in the sequence are 0 and 1, essentially 2 base cases. Each subsequent value is the sum of the previous 2 values, so the whole sequence is 0. 1, 1, 2, 3, 5, 8, 13, 21, and so on. Define a recursive Fibonacci method that returns the nth Fibonacci number with n equaling 0 representing the start of the sequence.
All right, so factorial and Fibonacci, you pretty much have to talk about these when you talk about recursion. It's just, I mean, every computer science book deals with this as their examples. So we are going to too. The only trick is you have to kind of understand how the Fibonacci sequence works before you can write a recursive method over it. So here we go. This is the way that Fibonacci is defined. It's a sequence of numbers. The first 2 are locked in. The 0th term is locked in at a 1. The first term is locked in at a 1. But after that, they all follow this formula. okay? The one on row 2 is equal to the sum of the previous two numbers. The one on row 3 is equal to the sum of the previous two numbers. The fourth, the term on row 4 is equal to the sum of the 1 and 2. So that's going to be
6.
nope,
5.
5.
Jeez Louise.
Hey, you know what? Props for putting yourself out there.
Yeah.
All right.
Yeah.
Now, redeem yourself here, Ruff. The Fibonacci of 5 is
8.
yeah. The Fibonacci 6.
13.
Yep. The Fibonacci 7.
21.
So we're going through this iteratively, okay? We could say that the Fibonacci of 8 is equal to the Fibonacci of 7 plus the Fibonacci of 6. Does that make sense, Rob?
Yes.
Now, what's the Fibonacci of 7? Without, imagine you didn't have that table.
Okay, it'd be 7 plus,
Would it not be Fibonacci of 6 plus the Fibonacci of 5?
yes,
Well, what would the Fibonacci of 6 equal?
the Fibonacci of 5 plus the Fibonacci of 4,
And the Fibonacci of 6 over here?
Fibonacci of 5 plus the Fibonacci of 4,
Whoops. What about this Fibonacci of 5?
Fibonacci of 4 plus the Fibonacci of 3.
Are you sure about that?
Yeah, I'm sure about that.
What about the Fibonacci 5 right here? You get where I'm going from?
Yes,
Am I ever going to stop?
yes,
Where am I going to stop?
at the Fibonacci of 1.
Yes. The Fibonacci of 1 equals 1. And there's another place I'm going to stop. The Fibonacci of 0 also equals 1. Those two are locked in. Okay? So, we need to try to figure out what is a base case and what is the recursive case. In this case, we are sent an integer n. So, if n equals
0 or 1?
0 or 1, we're going to return 1. Otherwise, which is the recursive case, we're going to return the guy previously, right? So f of, can you think about it, previous guy plus the previous guy. So what would the previous guy be? Come on in. You come bouncing back.
N minus 1?
Say it again?
N minus 1?
Yeah. What about the previous guy?
N minus 2.
Program 2, y'all can review and plan on taking those tests on Monday.
Okay.
So if n equals 1 or n equals 0, return 0, else return
Gymnastics. That's all it was.
Fibonacci n minus 1 plus Fibonacci n minus 2. What? Oh, I got them all wrong because I returned 0. got one of them to work.
On here, 0 should return 0.
Yeah, it says whose sequence is, you know what, you're right, because it's 0, 1, 1, 2, 3, so I didn't have it. So I guess I got this wrong, didn't I? It was 0, 1, 1, and then 2, 3, 5, 8, 11. I knew something didn't seem right. Okay. So, thanks, Melissa. So if n equals 0, she says return 0. If n equals 1, return 1. And then after that, for 2 and beyond, it should work just fine. Did I tell you about the Code Quest competition where they broke the servers? It was on this problem. Or well, it was like a Fibonacci type problem where they said find Fibonacci of 50. And everyone's like, oh, Fibonacci, let's do recursion. It's perfect, right? It matches this situation exactly. And it does, except it'll break your server after a while. You know, we get to like 40s and 50s and things like that. You're better off using, just building it iteratively. If it's 0, it's 0. If it's 1, it's 1. Otherwise, it's the previous 2. Let's try this triangle one. Rosa, can you read that one to us while I erase the board?
We have triangle made blocks. The topmost row has 1 block and the next row down has 2 blocks. The next row has 3 blocks and so on. Compute recursively with no loops and multiplication. The total number of blocks in such triangle will be given number of rows.
Okay. So you can imagine it looks like row 1, row 2, row 3. Is that right? Something like that? Topmost row has 1 block, then we've got 2, then we've got 3. Okay. Down to row n. We want to figure out the total number of blocks in a triangle. Now, if we were going to do this iteratively, we would just say for 1 to n, for I equals 1 to n, 1 plus 2 plus 3 plus 4. You could do a loop there, no problem. But we want to try to split this up recursively. Maybe what we could do is we could count how many blocks are on our current row right now, and then save everything up here for later. Does that make sense? So count this now, and then deal with the rest later. That's sort of our recursive step. So something like, how many are on our block at the very last one? I say that's n, right? So we'll say return the number on this row plus the rest, which means everything up here. Okay. When do we want it to stop? What's our base case?
1.
Yeah, 1. So if the row number equals 1, then you're at the end, right? Return 1. So if rows equals 1, return 1, else return. Somebody help me out here for this last sentence here.
Also return row plus 2 plus 1.
Not quite. It's rows, that's the part that I'm dealing with now, plus all the rest that I'm going to deal with later. Rosa?
What? Oh, plus triangle rows.
Yep. Remember, we've always got to have a. Oh. We did an overflow. That means it timed out. That means their code was smart and said, hey, if after like 20 milliseconds we're not getting an answer, we're killing it. It looks like I'm getting an error on triangle 0. Okay, fine. If rows equals 0, what should we return if they say 0 rows? 0. Fine, bat, be that way. Alright, so that was some recursive programs. I want to work those together. If you want to do some more, like I know, Rosa, you're in the UAL, I recommend that you give it a shot. Recursive programs kind of make your brain hurt in all the right ways. It's kind of fun to think through. We could do more, but there's some fun stuff we can do with recursion, like the toys. Alright, so guess who's going first, Ralph?
You.
What's your next guess?
That, I don't know.
Jean?
John's going first.
Alright, so here's the game. The game is, you have to get all of the rings from this pin over to this pin. Okay? No big deal. However, you can't move both of the rings at the same time. You can only move them one at a time, right? And you cannot put a larger ring on a smaller ring. Alright, oh, let's get him in frame.
Alright, what are we trying to
Do it.
Should I get it here?
Yeah, I'll get it there. You only move them one at a time.
So am I able to move this one over
You can
here?
move them all the way over there, or you can move them in the middle. Yeah, sure, that works too. Ding, ding, ding. Great job. Now, do it again. There you go. Yep, you got it. Yes, yes.
This is magic.
Good job, good job.
Oh, okay.
Alright. Remember, can't have a smaller one, a bigger one on top of a smaller one. You want to restart?
No.
Restart, trust me.
Okay.
Your first move was...
I was here.
Okay, so let's change the first move. Try there. Yep. Yes. Yes. Keep going. Yep. You're halfway there. You got the green one. Now, just transfer all of those. Okay, yeah, alright, that'll work. Might have been a slightly more efficient way of doing it, but we got it, we got it.
Oh. Wow.
Good job. Guess what's next?
No!
Alright, now, let me show you something. This is where recursion comes into play. So, what I'm going to do is, I want, obviously, all of them to get over there, but I can break this problem down into something I can solve now and something I can solve later. Essentially, what I really want to do is I want to get all of these to here, so then I can just do this with the blue guy, right? So, no big deal. And so essentially, if all of those are there, that becomes the problem of I want the green one here. Make sense? So if I want the green one here, then that essentially is a problem of what I really want is I want the yellow guy over here. right? If I want the yellow guy over here, then that means I want the blue or the orange one right there. Does that make sense? And then I can do that. So essentially what I do is I want to get the green guy over to here. So how do I do that? Well, I might do this. Oh no, wrong first move. So let's try. So I'll do that. I've got the green guy here. Now I'm gonna move. It's just a problem moving the yellow guy over there. So it kind of becomes one of these things. And I'm halfway there. I can pull this over, and I'm just gonna do that whole process again. So rough. Let's do it. Let's go red on green.
What?
Red on green.
Yes, but.
Trust me. Nope. Red on the green.
Oh,
That's where.
this is the red one. Okay.
Yeah, sorry, yes. No, that's the big one. Oh, no, orange. Then red right there, and you've got the green. You've got it, but it's on the wrong one. See what I mean? So we wanted the green guy on that middle pin. Gotcha. So let's restart.
I'm not very good at this. Okay.
So let's try to break it down a little bit. So we want to get the green guy right here.
Mm-hmm.
If the green guy's right here, then that means we want the yellow guy right here. Can you get the yellow one over here? I know you can. Just get the yellow one over there. Just focus on that. And get everybody on top of get everyone on top of the yellow guy. Okay. Now you've got the green guy there. Now just move the yellow guy on top of the green. See, that's not really, you haven't really changed much there. See, so you just move the yellow from one side to the other. Put the yellow, the orange, and the red all over back on that pin over here. Let's move that red to a different one here.
Did I already have it on this one?
I think you did. No, you didn't. Put the red there. Yep. Halfway there.
I don't know why I did that.
No, that's exactly what you needed to do. Because now we've got it. So think of, hold on. Go ahead, I'll stop you, I guess. You're on track. No, hold on. We're trying to get the green. Put the yellow back. Bring the orange and red on top of the yellow so we can move the green to the blue. Not at the same time. Yep. Alright. Yellow to that last side and you're good. Few extra steps, but you know what? That's fine. Hard part is trying to get it as fast as possible. Rosa, you want to give it a shot?
Yeah.
Give it to Rosa. Let's see what Rosa can do.
No.
We'll let Rosa give it. Rosa, you're good.
You're on track.
I don't know how to do it.
Figure it out. So start with 3.
Hi, John. I'm in charge of this video now.
No, that's too close. Move it back. I wasn't watching.
Here you go. Hold on. So 3 from there to that.
Oh. Oh, can I start over?
Yeah. There you go.
That one.
All right, and now we'll add a 4th one.
start over
Okay,
again.
that's fine. You get a 50-50 shot, so then you pretty much know the way that Yep.
This
Yep.
one.
You're
And I
good. You're good.
forgot. Oh.
Okay. Yep. She's thinking ahead. Hooray! Good job. All right. You thought we could. Bye, John.
Bye, John.
See you all.
on the camera?
I don't know. Can you?
Wow.